Have you ever wondered how a scheduling app just works? How it juggles tons of meeting requests without creating chaos? Well, today we're going to pull back the curtain on the exact kind of slick algorithm that makes it all happen. We're going to break down some pretty complex logic into simple, visual steps. And by the end of this, you'll see exactly how a computer finds that perfect, elegant order in what seems like total scheduling madness.
So just imagine this for a second. You're running a popular co-working space. You've got meeting requests flooding in all day long. Different times, different rooms, different durations. Your job isn't just to squeeze everyone in. It's also to figure out which room is your real MVP, the one that's getting the most use. It sounds simple on the surface, but doing it efficiently and, more importantly, fairly, well, that's the real puzzle we're going to solve today. So here's how we're going to tackle this. First, we'll quickly set the stage. Then we'll lay out our game plan. After that, we'll run a live simulation, handle what happens when things get overbooked, that's the fun part, and finally, we'll find and crown our busiest room.
Okay, before we just jump in and start assigning rooms, we need a solid strategy. A good plan is what turns a potential mess into a smooth, elegant system. So let's lay down the rules of the game.
Our strategy is actually pretty simple, and it breaks down into 3 steps. Step 1 is the absolute foundation of this whole thing. We sort every single meeting request by its start time. Why? Because it's the most fair way to do it. First come, first served. No special treatment, just a clean, logical queue. Step 2, we'll create a simple logbook for each room to track what it's doing. And finally, step 3, we just work our way down that sorted list, assigning meetings and updating our logbooks as we go.
So what's in this logbook I mentioned? It's basically our command center, but it's super simple. For every single room, we only need to keep track of 2 things. 1, what time does it become free next? And 2, how many meetings has it hosted so far? That's it. This incredibly simple idea is the key to solving the entire puzzle. All right, our game plan is set. The rules are clear. Let's put this machine into motion with some actual meeting requests. It's time to run the simulation.
Here are the bookings for the day. And hey, notice something? They're already sorted by start time, just like we said in step 1 of our plan. So we've got meeting A, B, C, and D, each with a clear start and end time. Let's get these things scheduled. And here's our workspace at the start of the day. We've got 2 rooms, and it's a completely clean slate. The logbook shows they're both available right now, at time 0, and of course, they've hosted 0 meetings. We are ready to go.
First up is meeting A, which starts at time 0. The algorithm scans for a free room, and boom, room 0 is available. It gets the booking. Now watch the logbook. Room 0 is now busy until time 10, and its meeting count just ticked up to 1. Simple enough, right?
Okay, next in line is meeting B, starting at time 1. The algorithm checks again. Is room 0 free? Nope, it's booked. But room 1 is wide open. So meeting B gets assigned to room 1. And just like that, the logbook for room 1 updates. It's now busy until time 5, and its meeting count is also 1.
So far, so good. Everything's been pretty straightforward. But now, this is where things get really interesting. What happens when a request comes in and all of our rooms are already booked? This is where the algorithm really has to show its smarts.
Now we've got meeting C, which wants to start at time 5. Let's check our logs. Room 0 is still busy until time 10, but look at room 1. It became free at exactly time 5. I mean, talk about perfect timing. Meeting C slides right in, no waiting at all. And room 1's logbook gets updated. It's now busy until time 7 and has hosted a total of 2 meetings.
And here it is, the moment of truth. Meeting D arrives requesting a start time of 6. We check our logbook. Room 0 is busy until 10. Room 1 is busy until 7. For the first time today, we have a traffic jam. There are no available rooms. So what does our system do? Does it just give up? Cancel the meeting?
This slide really lays out the 2 sides of our algorithm's brain. The path on the left, that's what we've been doing this whole time. If a room is free, you book it. It starts on time. Simple. But the path on the right, that's our new scenario. If all the rooms are busy, the system doesn't panic. It intelligently finds the room that will become free the soonest. And here's the absolute key. The meeting gets delayed.
And this is the golden rule, the elegant solution at the very heart of this algorithm. The meeting doesn't get canceled or cut short. Its original length, its duration, is sacred. It just has to wait its turn for the next available slot. And its new end time is calculated based on when it actually gets to start.
So let's apply that exact rule to meeting D.
It wanted to start at 6, but the earliest a room opens up is room 1 at time 7. So meeting D gets assigned to room 1, but its actual start time is pushed back to 7. Now, its original duration was 6 hours, right? 12 minus 6. So its new end time is its new start time of 7, plus its duration of 6, which gives us 13. And look at that. Room 1's meeting count just jumped to 3.
And just like that, the hard part's over. We've processed every single request, we've navigated the overflow, and our simulation is officially complete. Now, for the grand finale. Let's look at our final logbook and find our winner.
Here is the final state of our logbook. The data tells a really clear story. Room 0 had a pretty chill day. It only hosted 1 meeting. But Room 1? Wow. By handling that delay, it really put in the work, hosting a grand total of 3 meetings. So the very last thing the algorithm does is super simple. It just scans that meetings hosted column and it looks for the single biggest number it can find. And in our case, that number is clearly 3. That represents the peak usage that any single room had to handle today.
With that final count of 3 meetings, Room 1 is our undisputed champion. It's the most popular, the most booked, and officially the busiest room in our little co-working space. The algorithm found our answer, loud and clear.
So let's just do a quick recap of the core logic here. Rule number 1, always sort by start time. It's the only way to be fair. Rule 2, if a room is free, use it right away. Keep things efficient. Rule 3, if all rooms are busy, find the one that frees up the soonest to minimize the wait time. And Rule 4, the most important one, a delay is okay, but you always preserve the meeting's original duration.
And that's really all there is to it. That's how this elegant little algorithm solves the puzzle. But it does leave us with a pretty fascinating question to think about. Our system treated every single meeting as equal. But what if they weren't? What if you had VIP clients or emergency meetings that had to take priority? How would you change this logic to handle that? Well, that's a much more complicated puzzle, maybe for another